well, if you compare that to how smaller companies are actually working on this and what kind of well, problems they might have in terms of legislation and rules, but also, yeah, factors that kind of determine whether they can actually do what they want to do. So I'm really happy that that Jenny is willing to share her thoughts on this with us today. And with that, I would like to give you the floor, Jenny.
Thank you very much, René, for this kind introduction. Let me see if I can give you. Okay, do you have my screen in front of you?
Yes.
Thank you, great. Well, let's start with some worries from the shop floor, and that is immediately something that springs to mind if you compare the onderzoek at the hogescholen, the research at the applied universities with the more academic approach. Yeah, we always start practice driven. So what we have, if we talk with companies in our network, we see some concerns because there's a lot of new legislation coming up, like the right to repair index as part of the eco-design regulations, extended producer responsibility. So that raises a lot of questions, but it's also the case that a lot of the companies in our network have a really intrinsic motivation to become more circular, but well, how to start and what to do. That is our starting point for the project and the research we are running at our research group. But there's something that I should say though, because circularity, that is a very data intensive business, yeah, because we need to deal with traceability, diagnostics is very important, reliability engineering becomes part of it. And that in a time where many big, but apparently mainly small manufacturing companies still struggle with the concept of digital and smart manufacturing. So if I give a very quick overview of the IT landscape of a typical manufacturing company, then you have a lot of layers in the architecture. There's a lot of data communication between all different kind of applications and different processes and different resources. Dealing with that, well, that in itself is already quite complicated. And if you start working circular, then you add a lot of new open-ended questions to this puzzle. So that is something that adds to the concerns they have. So all the nice buzzwords from smart industry, yeah, that's cool, but it doesn't work that way always for these companies. So to put it in a very, let's say, a very cross way, there is a lot of problems with actually connecting everything together because it's a lot of old machines, new machines, different vendors. So hardware, it's connecting that is already complicated, but also the data formats are also different for each and every step in the process. So that already is quite complicated. And now with aspects of circularity bubbling up, that becomes even more difficult puzzle, because if you start to maintain material passports, product passports, all these kind of things, well, that has to fit in this already quite complicated picture as well. So that is to give you a bit of the background we're working against. And that's also where the remanufacturing lab of the Hague University comes in. So it is currently being developed as a learning factory, or you could also say a field lab, but to develop the capabilities for digitized, cost-efficient and safe manufacturing, but mainly remanufacturing work. And for the moment, we focus mainly on disassembly operations because we have to start somewhere, and all circular manufacturing processes start with taking apart a product. We have a nice multidisciplinary group. Well, I'm not going to read that out, but we have something for each and every background. And we also have a lot of people who worked either as a researcher or in companies for quite some time. So that gives a nice insights as well. And we work mainly with students for our demonstrator work. So that also gives a very nice dynamics in the group. Well, I won't go into all the aspects of residual value of products for reuse, although that is also a very interesting topic in itself. But we could lecture about that also for many hours. But for today, I mainly want to go into the aspect of disassembly, and then because disassembly costs are a significant part of the value reduction of reused product. So let me explain. If you have a new product, and then at the end of its service life, you want to give it a new life. In order to do that, you have to perform a lot of repair actions. But we know that disassembly is one of the most expensive bits of it. So if you want to develop an economically viable circular model, then you really need to do something about this aspect of disassembly. So that is another reason why we take that as a starting point. It's not the only thing that is important, but it is really relevant. Oh, next slide. Yes. So our research questions for now are that we want to gain further understanding of cost-efficient disassembly, and that it's around the three main questions: how disassemblability of products differs from manual versus automatic processes, because that is something we really don't know anything about yet in the field. The feasibility of realizing economic value by smart disassembly, and also, but that's a step further ahead, is whether there will be impact on the design for disassembly guidelines as we know them now, because a lot of very relevant work is being done in the design part, of course, for designing circular products. No discussion about this. That is really, really important. But we're also sitting on a huge pile of products that never have been designed for reuse. So there are a lot of challenges there as well. So that is where we mainly focus on. And we also try to find out what we can learn from that for future products to be designed and developed. By the way, you saw a workshop. You see that in the photo where people are actually manually taking apart products, because we still learn from that as well to determine the disassembly strategies, etc. So it looks a bit like one of the Bosch Flips workshops, but it has a slightly different target, because you're really measuring all kind of disassembly times, and also to give the people the feeling what they actually need to do. Yeah, so we see few steps in this whole process: disassembly, inspection, cleaning, and then what I call the re-ex processes for reuse, repair, remanufacture, refurbish. It doesn't really matter what kind of definition you use for that step. It is always it's always only done after these other three, like disassembly, inspection, and cleaning. And as we focus on the capabilities for now, we mainly look into how we can improve tools, and how we can generate disassembly instructions, and how we can have more skilled operators and more suitable tools for them. And these operators, that can be both robots and human operators. And we work a lot with cobots in the lab, and you probably know that, but a cobot is a collaborative robot, which doesn't need to be shielded from the people in the environment. So that's a very low threshold tool to work with students with. And for many companies, that will be suitable. Well, they are curious whether that will be a suitable investment as well. So that is one of the things we try to find out. If we zoom in a bit into the disassembly process, then you see that it has a constituent steps like classification of a product, identification. The difference between the two is that for classification, you look at the type, and for identification, you look at what unique product you have there with its unique history, some inspection, and then for the disassembly actions itself, that consists of tool changes, positioning of the tools, manipulation of the product, actually disconnecting the connectors in the product, and then sorting and removing the parts in your workstation or on your working table. And what springs to mind immediately is that if you do this manually, okay, then often having the product and some instructions and tools is enough. But if you do this automatically, then of course you need a lot of digital information as well. So a digital product model, you have to determine the disassembly path and targets. You have to make a plan and make instructions, code, these kind of things. So we really add a fully digital layer to this. And you have to realize that for a lot of products that are out there in the world, in the installed base, we do not always have the correct product information anymore. So you have to reconstruct that quite often as well when the product comes in. There are different techniques for that. That's also something we're going to look in more carefully, but let me not run ahead for the towards the rest of the presentation. So our first step is to see whether cobots can be applied in a suitable or efficient way in disassembly processes. For some examples, I want to show you a nice picture of our very first prototype of 1.5 years ago. I think it's best if I show that in YouTube itself, because it tends to buffer a bit better. Do you still see my screen now? And now with the YouTube video? Okay. So this is a very preliminary setup. It was a very simple requirements. It was a dummy product with 2 different types of fasteners. And the only requirement to the students was get this working, and they used a camera to detect the screws and the screw type. And what you see then is that they came up with some very necessary aspects of this demonstrator tool. So they have what you see here, kind of sorting system, because once you take out the fasteners, then you have to put them in different bins for type A and for type B. So that is what they made. They could recognize the position of the fasteners, and they could also recognize the type. And there is also a very clever tool exchange system in this setup. I will move forward a little bit. Okay, and now you can see that it puts the one, yes, it's just a screwdriver, it puts it over there in this bin, and then it takes another one. Yeah, so that was our first prototype, just to see whether this could actually work. It didn't tell us a lot about the suitability, didn't tell us a lot about the efficiency, but it gave us enough confidence to proceed with this. So I have some results of the follow-up projects as well. Yeah, so the first requirement was just a dummy product for our next this cobot, the disassembly cobot demonstrator. We put the target a bit more ambitious, so real product with a higher disassemblability index. I will get back to that in a second. With several disassembly and manipulation tasks required, and also by means of using a product model in combination with vision to actually disassemble the product. So here you see a photo of the follow-up demonstrator. Maybe you recognize the product, the real product we are disassembling here. It's a Fairphone. Maybe, yeah, you're probably familiar with that. So we cheated a bit there, because a Fairphone is a really simple product. Well, it's not a simple product, but it's very simple to disassemble it. It was fully designed for that. Yeah, so I make myself a very nice cockpit here, but keep pressing the wrong buttons. Yeah, so here you see the Fairphone once it has been dismantled, but it has been designed for repair, for refurbish, and the disassembly only requires a limited number of steps, few tool changes, and it has very good reversible connections. So while disassembling it, you probably won't damage the product. So for us, it was a perfect start to move one step further towards a proper demonstrator. So you see all these items here. They are put in a fixed position in a tray, because we put a unique ID on the tray itself, and by combining the position with that unique ID, we know everything about all the elements in the system. So that makes it a bit easier. So here you see the subsequent steps. First, you put it in this fixture slot, then you can remove the cover, then you can remove the battery, remove the protection bumper. Then you have to turn it around, remove the screen, the speaker, and the camera. So these were the steps that were part of the functional requirements of the next demonstrator. I mentioned the word disassemblability index, and let me give you a quick glimpse on what I mean by that. Well, if we, okay, now you have all the stuff in view. You have a few very well documented methods that allow you to express the disassemblability of a product. So you, for instance, have the method by Peters. It's in literature that uses a very detailed step-by-step calculation for disassembly times. But you also have, for instance, on the website of Circular Manufacturing, there is a document that says residual value calculations that also gives an idea about how you can determine the disassemblability of a product upfront based on its properties. I have no, I don't claim that we work with a very accurate disassemblability index for the moment, but what I needed in this stage of the research is a quick and dirty assessment of how difficult it will be to dismantle a product. That's all. So we made a kind of simplified version of this disassemblability index, and you see that it is mainly based on what you see at the right, the reversibility of the connectors, and then you see that the weld has a very low disassemblability index because it's very difficult to take apart a weld. A screw is quite high because that's relatively simple, and items like snap fits or Velcro, well, theoretically, and we'll come back to this later on, they are fully reversible. So that is why they have very high value. And then you see that penalties come in when the product and its connectors have been damaged, like for instance, a greasy screw. Yeah, you can never take that out by means of a cobot. So that is why you get a penalty there. But if you lock stuff in foam or something like that, then also the disassemblability of the product as such, that lowers dramatically. Getting back to this Fairphone. Oh, yeah, sorry, I wanted to show you back here. Yeah, so if you look at the Fairphone, that has a very high disassemblability index because for removing the camera, the last part, that only requires a few steps. All the items in it are all the fasteners are fully reversible, so that makes it easy. If you compare this with an iPhone, then it would be a lot lower. So on the side, we work on improving these indices as well, but that was not the main topic of my talk. And of course, I know that there are much nicer methods around, like this one by the Favio, but that is not fully implemented yet to make a quick determination of the overall disassemblability index of a product once it enters my disassembly cell. So that is something else we are trying to work on. But let me get back to the next prototype, because here we already made quite some steps. So I'll show you a little bit of the assembly of the Fairphone. No, it's going wrong here. Okay, too bad. Well, then I will do this one. And now you see that we already made quite some changes to the tool exchange system. You see that these fixtures have been improved. And now it can actually dismantle the Fairphone. And I left out quite a few steps because first you have to take it, then you have to take off the screen, you have to turn it around, but they all managed to get to this point. And then you see that the last elements are also taken out. So that was actually quite an encouraging result. And of course, now we need to have to speed ahead full throttle and working on more complex products as well. Yeah, so here you see the setup in a bit more detail. You have fixed positions in the dismantling cell where you can remove screen, remove the bumper. This should be the remove the cover and the battery and the positions of the tools. So with 4 and 5, and then at the right you see some details of the tools. So there was pneumatic suction cups implemented in 2 sizes actually, to take out bigger parts and to take out smaller parts. And there is at the top, at number 1, there you see the tilting skid, because you have to turn around the phone at a certain point. And that actually proved to be the most different process step for this production cell. And that is exactly an example where you see the difference between automatic disassembly and manual, because for a human operator, yeah, that's just a turn of the wrist. That's very simple, but for a robot to do this and to think it through beforehand, how you can do it in a controlled way and make sure that the item lands at the position you want to, yeah, that was actually well, the solution is very elegant with this tilting skid, but it takes a lot of time. So turning around stuff for a robot is expensive. That was one of the conclusions we came to. And if you then have a proper look at the way it was programmed for now, then you see a lot of quick fix improvements, because you can really optimize the path of the disassembly arm by switching both the positions of the slots where you put your product, but also the sequence of the tools. You can make it a bit smarter in preventing tool changes, and you have to be very sparse in your use of the camera if you can tell the cobot beforehand where the product is, because, for instance, because we use these fixed trays with these fixed positions, then it saves you a lot of calculation time in the back for the vision and the processing of that. So in the end, we only used it for improving the accuracy when we are already within let's say the bandwidth of a certain position, and then you only use it to check whether you find the fastener you expect. Because that's another thing about used products. Yeah, they have a spec, but they're not always conform with that spec anymore. So that's also one of the challenges we have to deal with in this project. And if you then look at suggestions for design, yeah, well, of course, these are very, very modest contributions, but one of the things that really helped was to dull the reflection of the screw heads. So just to make sure that it's not very, let's say, that it doesn't shimmer the light. So we've done that by putting a dot of paint on it. So that is something that a designer or a manufacturer could do already beforehand. And we would also advise for next time Fairphone to avoid the turnaround manipulations, just to make sure that all the parts are accessible from the same direction. Other more questions of more consequence are how you sequence the disassembly steps with the diagnostic steps, because you want to know beforehand what product needs to be replaced if you do a remanufacturing action. For now, we were only looking at the full disassembly, but if we look ahead into the future, then you do not want to take everything that comes into your remanufacturing factory. You do not want to take it fully apart. You only want to replace the parts that need replacing to get it as new again. So having a clever interaction between the diagnostics, maybe on-board diagnostics of the product itself, that would also help a lot. If you can already read that from the telephone screen, for instance, okay, you should change the battery. That's, of course, a stupid example, because that is something we know for a phone. But for a lot of other industrial products, we do not have that knowledge yet. So that is also direction that needs to be further evolved. Because by doing that, you can also reduce the processing steps and times dramatically. And it also saves you a lot of trouble in sorting out the parts afterwards, because that is also something that that quickly became very clear to us. If you have a factory where you put together stuff, where you assemble it, well, then the chaos reduces towards the end of the line, because you put everything together. But in remanufacturing, it only increases, because you take apart stuff and then you have to classify it. You have to make sure that you know the quality status of all the items that come from this product. You have to store it somewhere. You have to administer that. And then when you put it back together, then of course it is again implemented into a new product. So also in terms of your whole IT infrastructure, I said, okay, the material passports, that is something we need to worry about, but also the simple logistics of dealing with parts that are taken apart, that is also something that shouldn't be underestimated. So that's also a very interesting direction to research further. So just a few conclusions. very preliminary, yeah, because you only saw these two demonstrators. What's different for automated disassembly? Well, you really need to think about the tool exchange optimization. You need a product model, and you need to be able to reason about alternative disassembly paths, and you need to do that in an automated way. If you look at the disassemblability of a product, which you would do if you want to determine at the start of the process whether it is economically viable to proceed with the disassembly and the remanufacturing and the reuse and putting it back to market. If you want to do a quick assessment whether that is economically viable or not, you need to assess the disassemblability. But if you only do that based on the product properties, that is not enough. You also have to take into account the process and the resource properties, because these will probably change dramatically in the coming years. There will be new recovery facilities, new repair facilities, new disassembly, new remanufacturing. So everything we know about this should be reconsidered. And then you should be very alert for typical things a robot is not good at and humans are. So the piece of Velcro, that is just a very silly example, of course, but there is no gripper in the world that can do that with a robot. So that is so there need to be a lot of developments done there as well. And the aspect of sequencing, I already mentioned that. So taking it from these results, and we've done a bit more already, but I didn't put it in the presentation yet. We, of course, want to proceed with increased complexity of products, and also with products that have a lower disassemblability in itself. So you see an example product here. It's an electromotor where we're not working on the motor itself yet, but on a dummy of this motor. So now we move towards not only a real product, but also a real company, a real stakeholder here. So this is the part we're working on now. The cleaning of the product, that will be important for us in the coming year as well. We know that we need to do a lot in the back end of actually programming the cobots and the assembly pen generation. So that's something we're starting up with a few other hogescholen now. And to give you a glimpse on our final goal, this is once it will be finished and implemented, this will be our full learning factory as we are building it at the Rotterdamse Weg now. And there we can hopefully do everything I told you we are going to do in an integrated and an integrated manner from start to end. So that's it for now. Just a glimpse of what we're doing, but I hope it feels inviting to come and have a look.
It certainly does. Thank you very much, Jenny. I'll give you a real hand, and there might be some virtual hands also. Thanks for a great insight in what you have been doing. And I think you can already see from the first, let's say, trials that you had to what it is now, that already major steps have been made. So I think that's a very nice thing to see, and it also, well, it also gives you some idea what it can be, let's say, in a couple of years from now. So big steps are made and will be made in the future. If there's any questions from the audience, please either raise your hand or just open your mic. I can see Dave, you raised your hand.
I did. Is my mic on? I don't know.
Yes,
oh, great. It's working. I never know. Great. Thanks. Oh, that was super, Jenny. Sorry I was so late. I missed quite a lot. But I got the gist and I'm really excited. I put the question in the chat, or well, it's kind of a question, more of a statement, but I think you'll agree. I wrote in there, and this is something I know Renee and other colleagues have got a lot of focus on as well, about the Critical Raw Materials Act. And it's coming out and it's coming fast. There's also what I've looked at as a link to the eco-design regulation recast, which is being driven by the Critical Materials Act. And that's really interesting because there it is mandating design for disassembly. And you just mentioned that, like, that's a barrier. I think the plan is by the Commission, at least we understand it, is there'll be some priority technologies first, but eventually everything is going to be covered with this. So they'll do it in a stepwise approach.
Yeah.
And then so just to go on a little bit more, so really it looks to me like in the transition, the sustainable transition that we must do, it's about materials and material product passports, reman in this case, or refurbishing as the case may be, but also looping into recycling streams. Recycling as products go through reman operations, because parts come out and they don't get used again, they have to go into, and then eventually, of course, once it's gone through a number of reman cycles, it is deemed uneconomic and it will then go into so I just wondered if that's maybe a future opportunity with the things you were showing, the technologies you were showing, the data about material passports down to element levels. Suddenly we get something very rich where we can connect recycling up with reman. What do you think about that?
Yeah. Well, the reason why we started with this assembly is also a bit keeping all options open, of course. And so what we develop here is, I think it's relevant for all the steps on the R ladder. It doesn't really matter. The only thing we do now, indeed, by adding all this digitization for recycling, that might be a bit overcomplicating things. But I agree that maybe if you, there will be a connection. There will be a lot of stuff that will have to be recycled anyhow. So that's definitely something we have in the back of our mind as well. It's just, there's so much work to do.
Sounds like our next project.
Yeah, sounds really cool. Yeah, thank you for being here.
Thank you. No, great, thank you.
Levon?
Hi, do you hear me? Oh, I think for some reason.
We can hear you. Oh, yeah. We can hear you, Levon. So you can just. Yeah.
Oh, sorry about that. I think for some reason my camera jumped into my phone instead of my laptop. Things are getting much smarter than we are these days. Thanks, Yanni, for the talk. I'm Levon, finishing my PhD at CML. I just had a quick question. Very interesting presentation. You mentioned in the beginning that the overall impacts in the end, we depend a lot on the energy use needed for such disassemblies, for repairs, compared to the lifetime extension, routing extension itself. Did you have a chance to assess, because I have no idea how energy efficient are these robots and machines? Did you have any chance to assess is that part of the impact in the end?
No, we fully realize that this is an important aspect, but if you look at we didn't look into the energy efficiency at all yet, and that's also a bit driven by if we want to be this a very lean process in the end, so that also includes being energy efficient. What we do look at, but not in a very detailed way yet, is that you also have to be material efficient, because that's where we focus on for now. So you see that, for instance, for milled parts that are taken from a big volume block of steel, then remanufacturing almost always pays off, because there would be so much new material required. But for some other parts, that is because they are already quite material efficient. Then the effort you need to put in, and sorry, I do not know the energy and the footprint related to that yet. That would be quite high, and then maybe doesn't pay off, and then it's better to recycle this part instead of investing a lot of material and energy in making it as new again. We are not that good in setting in determining the trade-off yet. That's one of the other items on the a lot of open-ended questions.
Totally.
Yeah,
makes sense. Then I'll try to keep an eye on your future results. And
and you know what, I also want to provoke by just starting with some stuff. I know that there are some other research groups that are considering to go into this as well. So if we can make this into a bigger community with a few of these assembly and reman labs, then we can focus on aspects, all of us, and then we will move and proceed faster than we can do now.
Okay.
I also have a question, Jenny. So thinking about where this kind of technology will be in 10 or 20 years from now, maybe. At the moment, you're working with products that you know, so you already kind of predetermine where are the screws and how is the product made, etc. So is the idea that you will do this for specific companies for their own products where you actually indeed have all this information, or would there also be a future in which you can just throw anything, let's say, at the robot and it will just figure out where the screws are, and because you were also saying, well, we have to limit the amount of processing of the video data because it takes a lot of time, etc. But do you think that we will end up with a system where we can just throw everything at the robot and it will just figure it out itself, or is this really meant for specific products?
Yeah. Well, with respect to the future scenarios, for me, that's also a bit of crystal ball glazing, of course, because you could envisage a future wherein there will be dedicated remanufacturers who will actually take a lot of different products and just throw it out. The companies we work with now, they are mainly motivated to offer products as a long-lasting service. So they just want to have a fully reversible assembly and disassembly process. So that is for us the starting point. But the other option might be just as likely as David indicates. There is of course a very relevant link with recycling as well. So maybe you would have pre-processing plants that take it apart to a certain level, then you do the diagnostics, and then you do as a service for other companies, you start to remanufacture. That could also be a very interesting development, but I don't know.
Yeah, I know. I've been working with Stichting Open, the organization that collects all the electronics waste in the Netherlands, and they're really struggling with the fact that they know that there are some product groups that might contain valuable materials, but they struggle with indeed the disassembly of these products because they're all different and they do it all manually now. So it's hard to envision a future where a robot would take this over. But of course, well, we don't have a crystal ball and technology develops quite quickly. But from that perspective, let's say from the collector of a diverse group of products, do you see any possibility there?
I think once the digital product passport will start evolving a bit further, then we will have a lot of data on products and their properties. And I think it will be, well, of course, I'm always optimistic, but it will be possible to actually, by making a scan of a product or just scanning its series number, you can probably make a quite accurate estimate of the kind of items you can expect in this kind of product topology, because we will have more information about that. And so in that way, I think with the clever use of vision, the bit of information digital information you have on the product, and doing a lot of reasoning and generative AI, you should actually be able to predict with some certainty what you can expect, so the robot could anticipate on that. I also know that this sounds like a very nice plan, and that in practice there will be a lot of problems, of course. So that is why you also need to have very versatile and agile robot technology to deal with this. So I think it's worthwhile a try. I'm not sure how far we can get.
Yeah, thanks. And relating to Levon's question, using a lot of AI and computing power will probably also use a lot of energy.
So that's horrible dilemmas. Yeah.
Hopefully that will all be solar and wind energy at that time. So anyways, Jaco.
Yes, thank you for a very interesting presentation, Jenny. Oh, sorry, a bit of sore voice. So I indeed also wanted to point to what is already interesting and quite core to what needs to be done and remanufacturing, so on the ground. But of course, it also needs like digital product passports, but it also will need quite some changes in governance and policy to get this widely implemented and upscaled. So my question would be, how would you relate this, or how could it benefit from extended producer responsibility? Is it just a matter of remanufacturing, or what do we need to do on the EPR to promote or make this remanufacturing stronger? Because we see that it's quite a bit of neglected in the discussions and also in the policy measures. And I'm just wondering, what are your views on this?
Yeah. Well, I'm always trying to be a bit cautious in making very bold statements on this, because the legislation is really not my field of expertise. But but my feeling is, if you can extend the life cycle, okay, then you definitely delay the moment when the extended product responsibility hits. So that is always to the advantage of the company. But it also, working on the remanufacturing makes you very aware of what can be reused, what cannot. So companies who already take this step of giving a product a second life, they will have a lot less trouble to make sure they comply with the extended product responsibility. So if you reason like that, it makes it a bit easier for them. But I think your question was the other way around. If we have extended producer responsibility for more product groups, will that help to strengthen the remanufacturing case? I think that was your question.
Yeah, well, at least part of it.
Yeah,
that would be a good one. What would be your view on that? Any ideas?
The very pragmatic answer to this is, I think it would help a lot, because only then will companies start to consider this business model.
Yeah, that would say David already referred to a next project, and it would be interesting to include that parts, policy-oriented parts as well, I think.
Yeah. Okay. Oh, yeah, that's also what David is commenting now.
Yeah.
They take action because of the regulations. Yeah. And that, of course, depends a bit on in what product group you're active or what the size of your company is. But yeah, they will have to. That's an answer. Yeah.
Okay. Nice. Would be nice to explore that further, maybe together, but that's for another time.
Yeah.
So thank you.
Any other questions from the audience? I noticed that Dave wrote something in the chat about that he has been in a lot of the companies at the in recent time, and that regulations basically drive them to take action, right, Dave?
Yeah, I mean, I'm sure there's no big secret. I was in ASML yesterday, and they do a lot of good things for a lot of good reasons. But in the end, it boils down to at board level and senior level and investment level, there is an increased urgency. I think it's to do with time and pace, how fast companies are moving. And there is as colleagues know, there is an absolute snowstorm of regulation coming out of Brussels, which is driving them to move a lot faster.
Yeah.
I would say this, wouldn't I? But I do have concerns about how fast we in academia and research and education can upscale to meet their demand.
Yeah, that is exactly what I wanted to add to this, because we already missed projects because they say, okay, well, will it take a year? Okay, then we're not interested.
Yeah. And it's funny, you go to a few companies and I've been all over Europe. I just did a roadshow across Ireland. I saw about 50 companies on a 1,600-kilometer roadshow of critical materials and reman across Ireland. And you get a relatively small member state like Ireland, and suddenly you realize the entire Netherlands capacity of knowledge could be absorbed in one small member state of 4 million people. And we've got an EU of nearly 400 million, and they're like, sorry, we're just nowhere near at the capacity and scale we need for the speed. It's a time problem. I've always said this. But critical materials, energy transition, sustainability, everything is a time problem. And because what we've done is wasted too many years of time, and now we don't have time. And so upscaling fast on our side of things, on education and research, I think is our grand challenge. And I encourage earlier stage researchers that are on the call and listening, consider joining us in academia and supporting us, because we need more of you. But there's another question.
Yeah, thanks, Dave. Lavon?
Yeah, thanks. If we still have time, I had a slightly more theoretical question. You introduced the Gambler Index, which I myself was not familiar with before. The whole field is rather actually new to me, and I was curious, is it heavily correlated with the repairability index or score? Would you think of the examples where the product can be highly repairable but not be easy to disassemble, or vice versa? Or basically those two indexes are always hand in hand with each other? If the question is clear, it would be nice to hear what are your thoughts on that.
I'm sorry, Livon, I didn't grasp the full question because the sound quality is not optimal, but I think you said something about the correlation between repairability and something else.
And this assembly index you introduced, yes.
Oh, okay.
So if
yeah.
These two are always basically hand in hand with each other, and one leads to the other, high score in the other, or there are examples of products being good on one side, but actually pretty low on the other?
Yeah, that is nice question.
Thank
I'm
you.
not very familiar with all the alternative definitions of repairability index. I know there are a few, and there are a few nice papers on this as well. What I remember from them is that the disassemblability of the product is a huge chunk of the repairability index. And the way I saw those indices defined, then yeah, there was always a correlation, because the disassemblability was an inherent part of the repairability. So in that way they were linked. But if I'm not mistaken, but there might be people in the audience that know more about this, but for the repairability index there are a few additional requirements, like the accessibility of spare parts, the accessibility of repair instructions, those kind of things. And that is of course not directly related to disassemblability. So put it like that, there could be products that are very easy to disassemble, but if there are no spares left, then you can still not repair it. So yes, there is not very, that could be the case. And that is exactly one of the...
Yeah, makes sense. It makes sense. Yeah.
Yeah, and that is one of the things with the legislation. It would be very easy to sabotage this new legislation if you say, okay, yeah, well, I fulfilled all my requirements, but unfortunately, there's no company on the earth left that can supply us with this missing spare part, so we still cannot fulfill our repair requirements. That would be very easy to say. But luckily, we know from other branches of industry that there will always people who jump in and will start reconstructing this. But yeah.
Okay, so it sounds like if the repairability score is high, it automatically implies that it has to be highly disassemblable, whereas the opposite is not necessarily true. So if it's the disassemblability score is high, maybe it's still not repairable either. Okay, yeah, it makes sense what you're saying.
Yeah.
I'm actually jumping in few weeks into this new project with ACML on the repairability of their machines, trying to assess them at the design stage. But as I said, again, the field is new to me, and the concept of disassemblability I heard of for the first time, to be honest. So it's interesting for me, useful for me to learn from about these concepts actually.
Okay.
Thank you.
Thanks again.
Thanks. And I don't see any other questions, and we are about running out of time anyway. So I would like to thank you, Jenny, for a great presentation and sharing your insights here. I'm hoping to see more of your work in the future, and maybe I'll visit at a moment, because I really like to see these things that you can actually touch. And because we always do theoretical stuff and we write stuff and we make calculations and make nice models, but it is also nice to have stuff that you can actually see working.
Yeah. Well, that sometimes works. Yeah, that's. But well, I think within a few weeks we'll have our next our successor running, so that will be interesting.
I already saw in the chat that Dave will want to join me there.
Yeah, good. Well, thanks a lot for having me. It was a lot of fun to have this discussion for me as well. So thanks.
Thank you. Okay. See you next time. Bye-bye.
Bye-bye.